Hey, practice test part 2, problem solving. This is not an exact match to what's on the test. I'm just including it here, some problem solving problems, just to give you an idea of what you might see. But like I said, this is not exactly what's on the test. If you want to know all the problem solving, you should look at the ones we did for Clue, look at the adding, subtracting ones we did in class, and that will help you a lot. But here's some from the practice test. Then what we have is distance, the mean distance from the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And we want to first change these to scientific notation in kilometers. So I'm just going to go 5.79 times 10. I'm going to just start with my lead factor because that's pretty easy. 1.496, 2.279, 7.784, 1.4294, 2.875. Notice there can be as many digits as you want in that lead factor as long as it's between 1 and 10. Now I have to figure out the power. Remember, I start here and I count over 1, 2, 3, 4, 5, 6, 7. Seventh power. This, I'm going to do a little trick. This is 3 to that comma. That's 6 to that comma plus 2 more is 8. A little bit easier. Here, 3, 6, 8 again. Here I have 3, 6, 8 again. 3, 6, 8 again. Here I have 3, 6, and then 9. So this is to the 9th power. And then this one, again, 9. And the last one is also 9. So that, a quick way, just count in groups of 3 because the commas are there to help you, and then add on what you need. So now I have it in scientific notation, which is this part. Convert to AUs, which is astronomical units, by dividing each planet's mean distance from the Sun by this number, 1.496 times 10 to the 8th. Use scientific notation, round your answer. So here's a little example of how to do it. I take the lead factor here, and I divide it, and then I subtract exponents. So notice this one is less than 1 astronomical unit. Thinking other science there. All right, so let's look at Venus's distance. Venus's distance is 1.082 times 10 to the 8th divided by 1.496 times 10 to the 8th. Well, if I subtract the exponents, I get 10 to the 0 power. And then 1.082, let's see what that gets. I'm going to use a calculator. You can use calculators here. You'll be able to use calculators on the test. So that will be nice. Divided by 1.496. And it gives me 0.72. And round to the hundredths place, 0.72. And then I'm going to make that scientific notation, which would be 7.2 times 10 to the negative 1. 7.2 times 10 to the negative 1. Sorry, you don't need to turn it back into scientific notation because we want astronomical units. And that would be 0.72. And now let's look at the next one. Let's look at Mars's distance. So this was Venus. I'm going to do Mars. I got a little bit of room here. I'll start over here. Mars is 2.279 times 10 to the 8th divided by 1.496 times 10 to the 8th. It's going to be 10 to the 0 again. Let's see what 2.279 divided by 1.496 is 1.5 about. So this one's going to be about 1.5. Jupiter is 7.784 divided by 1.496, and it's going to be 10 to the 0. Look at that, I did a little shortcut. I didn't need to write it out anymore, I know it. I like shortcuts in math, they keep it easy. 5.2. And what do we have next? Saturn. I got 1.4294 divided by 1.496. And this is going to be times 10 to the first power, because this is 10 to the 9th, 10 to the 8th. 9 minus 8 is 1. So let's see what we get. 424 divided by 1.496. And I get 0.95 times 10 to the 1. So if I multiply times 10, I get 9.5. So this would be 9.5. I get a little bit more room over here for Uranus. And I get 2.875 divided by 1.496. And this is going to be 10 to the first power. 875 divided by 1.496, and it gives me 1.92 times 10 to the first power, which would be 19.2. And the last one, but not least, Neptune, I'll do over here. Neptune is going to be 4.5043 divided by 1.496. And you can see when you divide the lead factor, subtract the exponents. This is just a little repetitive, sorry. But it'll give you good practice on dividing exponents, or dividing scientific notation. And this is about 3.01 times 10 to the first power, which is about 30.1. So now we have the astronomical units, mean distance from the sun. We have it in scientific notation. We have it in standard notation. That's pretty cool that you can do it in all those different forms. I like that about math. There's a lot of different ways to do it. It says approximately how many times greater is Saturn's distance from the sun than is Earth. So Saturn's distance, and I'm going to do it in scientific notation because that's what we're working in. Saturn's distance is this, 1.4294. 1.4294 times 10 to the 9th. Earth's is, I got to go back up there, 1.496 10 to the 8th. I subtract exponents, and now I do my division. And when I do that, sorry, I was thinking for a second. It's always good to think. You know, I lost my train of thought, as you guys often do when you're doing a little bit of work. I got 0.96 times 10 to the first, about that, which would be 9.6 times greater. So it'd be 9.6 times greater Saturn's distance. Approximately how many times greater is the distance of the farthest planet from the sun than is the distance the closest? So the farthest planet is Neptune, 4.5043. Times 10 to the 9th. The closest planet is, oh, where'd it go? Mercury, 5.79 times 10 to the 7th. That's going to be 10 to the 2nd. Let's see what our lead factor is. Divided by 5.79, and I get 0.78 times 10 to the 2nd power. You can do 7.8 times 10 to the 1st, or 780 times greater. That's a lot. Jeez, what a huge universe. And let's look at this last one. Just for fun, I wondered how far Earth would be from the sun if you squared the distance. So the distance Earth is from the sun is this one. Remember, that's Earth. So I'm going to take Earth's distance. And I want to square it. And to square it, remember, when you raise a power to a power, you multiply the exponent, so it'd be 10 to the 16. And then I do 1.496 squared, and it gives me 2.238. So I'll say 2.24 times 10 to the 16th kilometers from sun if I squared it. Well, that's pretty far. The second part is use scientific notation. Do you think it would still be in our solar system? And I'm going to say no, because it is much farther than Neptune. I mean, Neptune's 10 to the 6th. This is 10 to the 7th times farther. That's a lot. And I just don't think it would be in there. All right, so there's a little bit of problem solving. Here's your rubric. This is the actual rubric that you'll use. So you'll have an idea of how you'll be scored and how you'll score yourself. Hopefully that little video helped a little bit. And that's all for me.